3 words changed everything at Tesla. Aluminum actually works.
Nobody's done it before, and it really took a tremendous amount of effort within Tesla engineering to figure out how do we make a freaking Tesla cell and have it actually work.
How long does it take to fully charge?
To half an hour. For an electric car, you'd want to actually go very close to zero.
For decades, every battery scientist on Earth knew aluminum was impossible, too slow, too unstable, too worthless for real power. But in a sealed Austin lab, Tesla just turned the most abundant metal on the planet into something that makes lithium look like ancient technology. 5-minute charging, 550 miles of range. A battery that gets stronger with age instead of weaker. And a $16,000 car that just broke every rule the auto industry thought was unbreakable. For over a decade, the story of electric cars has been chained to lithium. It powered everything from Teslas to Toyotas, from laptops to smartphones, and it was treated as the unquestioned king of battery chemistry. But underneath the hype, everyone in the industry knew its cracks. Lithium was slow to charge. It lost capacity the longer you used it. It overheated under stress, sometimes catastrophically, and the global supply chain that fed it was fragile, expensive, and politically unstable. Every improvement came in tiny steps, shaving a few minutes off charging, squeezing out a little more range, but the core problems never went away. The industry was stuck playing a game of patching flaws instead of breaking free. Tesla refused to play the game, while the rest of the industry obsessed over squeezing a few extra drops out of lithium. Tesla quietly asked a different question. Why keep fighting a material's weakness when the answer might be hiding in plain sight? In Austin, a small team of engineers turned to aluminum. Ordinary aluminum, the same cheap, abundant metal found in soda cans and airplanes. Everyone else had written it off years ago. Aluminum could store energy, yes, but it had one fatal flaw. Once charged, it couldn't release that energy quickly enough. Scientists called it ion lock, and for decades it was the reason aluminum batteries were dismissed as a dead end. But Tesla didn't see a dead end. They saw a new challenge. By embedding aluminum into a carbon graphene substrate engineered with atomic scale induction points, Tesla cracked the code. The ions that had always been trapped, sluggish, and unresponsive suddenly moved as if set free. Energy wasn't just stored, it could be unleashed instantly. Overnight, the old limits that had defined lithium no longer applied. There was no overheating spiral, no fragile supply chains holding production hostage. Just a raw, abundant material turned into a power source unlike anything seen before. And then came the part that really stunned insiders. Tesla didn't just solve aluminum's chemistry problem. They rewrote the way batteries deliver power. They called it quantum burst control, or QBC. Traditional batteries push energy out in a steady, controlled flow. But Tesla's new design shaped power into rapid, precise bursts, firing so cleanly and so fast it felt like the car was predicting the driver's foot before it even touched the pedal. In the lab, the numbers looked unreal. Output over 7,000 watts per kilo, more than 5 times stronger than Tesla's own 4680 lithium cells. And where lithium cells struggled beyond 40 degrees Celsius, Tesla's aluminum packs actually came alive at 85. Instead of choking on heat, they thrived in it. Engineers described the difference like going from a garden hose to a fire hydrant. The same water, but unleashed with unstoppable force. Tesla wasn't interested in dropping this new battery into their existing lineup. They wanted to build a car designed around it from the ground up. Inside the company, the project was codenamed Redwood. Outside, the world would come to know it as the Model 2, a compact EV with numbers that sounded like science fiction. A starting price under $16,000, a range of 550 miles on a single charge, and most shocking of all, a recharge time of just 5 minutes. Prototypes were tested in silence, wrapped in plain black disguises, pounding laps on closed tracks. Journalists lucky enough to ride inside didn't know what they were experiencing, only that the car launched harder than anything else in its class. 0 to 60 in just over 3 seconds. No overheating warnings, no throttling, no fade. It simply kept delivering. lap after lap, as if the rules of battery technology had been rewritten before their eyes. For decades, aluminum was the joke material of battery science, too reactive, too unstable, too slow. But Tesla turned those weaknesses into strengths. By embedding the aluminum in graphene-like crystalline layers, they discovered something wild. Instead of degrading with heat, the structure actually grew more efficient. In deserts, on racetracks, under the heavy loads, the performance didn't collapse, it climbed higher. And unlike lithium or cobalt, aluminum isn't locked in by scarce mining sites or fragile politics. It's the third most abundant element on Earth. That means no bottlenecks, no geopolitical bargaining chips, no artificial scarcity driving prices through the roof. Just a raw, scalable material that could power millions of cars without waiting on supply chains to untangle. This wasn't just a step forward, it was a reset of the rules. When Tesla finally revealed the prototype in a private investor demo, they didn't hold a press conference or build hype with cryptic tweets. Instead, they rolled out a plain black Model 2 under fluorescent lights, plugged it into a standard supercharger, and started the clock. What happened next silenced the room. 5 minutes later, the battery was at 80%. No exotic infrastructure, no oversized cables glowing red under strain. Just a normal charger and a new chemistry moving energy at speeds no one thought possible. Even more shocking, the pack barely warmed up. No fans roaring, no coolant gushing. Just a calm, clean surge of energy filling the cells like liquid light. One of the biggest excuses people use to dismiss EVs. Charging takes too long, vanished in a single demonstration. And Tesla wasn't finished. Most batteries start dying the day they're built. Every full charge and discharge shaves off a little capacity until, after a few years, range anxiety creeps back in. Tesla's aluminum cells flipped that narrative. Instead of degrading under stress, the structure realigned and strengthened, almost like muscle after training or bone healing stronger after a fracture. Engineers pushed the packs through 500,000 full cycles, and the results came back unchanged, still delivering 100% of their original capacity. That's over a century of daily use without fade, a battery designed to last longer than the car itself. The implications are staggering. For consumers, it means buying a car that doesn't lose value just because its battery ages. For Tesla, it means producing fleets of vehicles that never need pack replacements, slashing long-term costs and reinforcing their reputation as the only automaker consistently pulling the future forward. And then there's regenerative braking. In conventional EVs, regen is useful but imperfect, capturing some of the energy lost during deceleration. Tesla's aluminum system made it absurdly efficient, up to 98% capture. In city driving, that translated to an extra 20% range without even touching a charger. The battery wasn't just storing energy, it was recycling it with ruthless precision. But chemistry and performance mean little without production. That's where Giga Mexico enters the story. Unlike traditional plants bogged down by water-intensive processes and endless bottlenecks, Tesla designed its new hub for speed and sustainability. Using a dry electrode method, they cut production time in half and eliminated billions of gallons of water waste annually. From raw aluminum to finished packs, the turnaround took just 72 hours. Yet Tesla's vision didn't stop at one mega plant. They sketched a swarm of micro-factories scattered across the globe, each capable of producing up to 1 million packs a year, smaller, faster, harder to disrupt. These autonomous hubs broke the stranglehold of centralized lithium supply chains. For the first time, battery production looked like something that could scale globally without political choke points or shipping delays. Energy independence wasn't just a slogan, it was baked into the factory design. And then came the moment that made every early tester grin like they'd glimpsed the future. Press the accelerator and the car doesn't just move, it reacts instantly, hurling you forward with torque that refuses to fade. Lap after lap, steep hills with trailers, stop-and-go traffic, it didn't matter. The performance stayed brutal and consistent, as if the machine wanted to go faster with you, not in spite of you. Tesla's AI-driven power management blended seamlessly with the new chemistry, adapting in real time to the road, the driver, and the conditions. It felt less like operating a car and more like partnering with something alive. For years, critics claimed EVs couldn't replace combustion because of 4 barriers: charging time, limited range, short battery life, and high cost. In one sweep, Tesla demolished all 4. 5-minute charging, 550 miles of range, a battery that thrives on stress instead of dying from it, a compact car priced like an economy sedan. The excuses are gone, and with them, the comfort zone of Tesla's competitors. Because the race is no longer about catching up, it's about surviving. The old rules of battery technology have collapsed, and Tesla is already building the future while the rest of the industry clings to the past. And that's the part most people miss. This isn't just about another electric car. It's about energy itself, how we store it, how we deliver it, how we build independence from fragile systems that were never designed for a world of 8 billion people demanding more power every year. The shift doesn't roar like an engine. It doesn't scream with smoke or flame. It hums quietly in the background, in cells of aluminum and graphene, waiting for the moment when the rest of the world realizes what Tesla has already built. That moment is coming fast, and when it arrives, it won't just rewrite the story of cars, it will rewrite the story of power.